Okay, so if you look at the first, the top four, it says write each set of numbers in set builder notation and interval notation. Problem 1 and 3, there is no interval for those ones. Now, the reason there is no interval for those ones is because of the fact that, remember, an interval is if you took like a section of the real numbers and colored it in. So, you know, it not only includes like 2 and 3, it includes all the decimals in between. So like 2.1 and 2.2 and 2. It includes everything. So there's no way to put 1 and 3 in an interval. Okay, so let's do the intervals first because the intervals are important. Let's do 2 and 4's interval. So the interval notation, you put what the variable is, so that x equals, for this particular case. If they use n, use n. If they use m, use whatever variable they use. They'll probably use x's or y's, I don't know that. Anyway, and then we think about what it would look on the number line, like this one. We would have an open circle at negative 6.5, a closed circle at 3. And so our interval matches that perfectly. So we have an open parenthesis at negative 6.5, a closed parenthesis at 3. That interval indicates that we would be using all the decimal values between negative 6.5 and 3. We would include the 3, but not the negative 6.5. Okay. Now, if we were to graph number 4, put your values down. We want less than 0. There's no equal to, so open. So when I color in an arrow going to a direction, I put what it is. Again, drawing is optional, but it is super helpful. Open circle at 8, color it in. I put the infinity there just as a reminder. Now, interval notation always goes in exact number line order. So it's going to go from negative infinity up to 0. It needs a parenthesis, and then our union, and then 8 to infinity. Okay? Okay, so that is the interval part of things. Let's do the set builder part of things. Okay? Now, the easiest ones to do set builders for are 2 and 4. Okay? So now let's do the set builder notation for 2 and for 4. Okay? Now, the way that you're going to do it is, all you're going to do every time is you put the first wiggly bracket or parenthesis thing, and then x, and then such that. Okay? Now, for one like this that has given us an inequality, the next thing you do is write the inequality. So it's going to go, you just write it down. Negative 6.5 is less than x is less than or equal to 3. Same thing here, x is less than 0, or x is greater than 8. And then you put a comma, and you say that it was a subset of the reals, and you do that in a very quick, easy way. X is an element of the reals. X is an element of, that's what that little e means, of the reals. And just any kind of capital R is good. The most common one in a math class, if you were in college, will be that double back R. That's the most common that a math professor would write on a sheet of paper. But if it's in a book, it might just be a bold capital R or a very kind of cursive-y capital R. Okay, now let's jump over to 1 and 3. We need to talk about the actual set builder notation because that's the only notation we're allowed to use or can use for those ones. So we're just going to call it x's again. You don't have to. You can, n is common, but all numbers, you know. Okay. So x such that begins all of these. Okay. Now we need to create a rule that fits this. So our x's in the top one, we could say would be greater than or equal to negative 3. See how it's going perfectly. Negative 3, negative 2, negative 1, 0, 1, 2. What kind of numbers are those numbers? That they're those perfect ones on the number line. What set is that? Includes the negatives. Do you remember what set that was? Reals are all of them with the decimals. Okay, so after reals, there's rationals, there's integers, there's whole numbers, there's counting numbers. So which one includes the negatives? Whole numbers go from 0, 1, 2, 3, 4. They don't include the negatives. We want the integers. Okay, so these are integers. Now, if you just said x is greater than or equal to -3 and x is an integer in words, I'm going to give it to you. So if you can't think of the abbreviation, go for it. But technically, we should say x is a member of or an element of z. Z is the abbreviation. So look over those abbreviations tonight. Okay, look over those abbreviations. Now, 3, we need a different rule. Multiples of 2, you just say that x is 2 times some number. And what kind of numbers are they? The numbers are integers again. Now, if they said positive multiples, we could say whole numbers. And I'm going to cut you some slack with those because it wasn't something that, to me, we'll use too often. As definitely you want to know how to do 2 and 4. 1 and 3, I think I only put one of those on there. Okay. Everybody get what we did for 1 through 4. Okay. Numbers 5 through 9 ask whether or not y is a function of x. So let's take a look at 5. Remember, y is a function of x. If x is my input, there's only one y output. Okay? If x is my input, there's only one y or f of x output. Now, let's do 6 and 7 first, because they're the easiest, and then we'll backtrack a little bit, okay? 6 and 7, you can use the vertical line test. Vertical line only hits it once. Vertical line only hits it once. Vertical line only hits it once. No matter what, that's a function. That's yes. That's a function of x. Here, a vertical line, there's quite a few places, really an infinite number, that it hits it twice. So that's not a function. So the vertical line test is a great way to really determine what's going on. But if you don't have the vertical line test, I want to talk about how you can tell if it's a function. So let's look at 5. The input value x is a car's license plate, and the output value is the make and model. Okay? This is the way I think about it. If I have a license plate of ABC, how many cars are allowed, that's our output, the car, how many cars are allowed to have that license plate ABC? Just one. So that's the way you can kind of determine how many, if I use that license plate, how many cars are allowed to use it? Only one. And so that's a function, yes. So you think about, if I use that x, will it only be used in such a way that it's paired up with something perfectly just once? So that output is only just one thing. Okay. Let's look at 8. If you can solve for y very easily, in this case we would add x to both sides. So y equals 4x. If the y is just a y without anything, no absolute value on the y, no square on the y, no power on the y, it's a function. But specifically, if you can get it into y equals mx plus b form, if you can solve for y and get it into mx plus b form, it's a function. It's a linear function. It's a line. It's perfect. It's lovely. It's wonderful and great. 9 is not. See how there's a square on the y? If there's an even number on the y, when you go to solve for the x, you get a plus or minus thing happening, and so it messes it all up. So this is a no, but specifically too, if you were to look at the function of this, and don't expect that this is to scale or anything, but this function, I believe, is a parabola laying outside. See how that fails the vertical line test. So if you know what the graph looks like, you can always say yes or no. This is a no. okay? Now, on the quiz, I'm going to put pretty straightforward ones. I'm going to do some with the graph, and then I'll put some with that are pretty straightforward. You can tell whether or not it's a function of x. Okay. Now, let's talk about inputs into functions, 10 and 11. Now, there are quite a few inputs into functions for the test, okay? So that's an important skill. So let's just practice doing that. If we plug in -1, sorry this is fuzzy, but if you plug in -1, you get -1 squared minus 8 times -1 plus 1. If I plug into a negative into a function, I like to put parentheses around it. That is helpful. And so you get 1 plus 8 plus 1, or 10. I'll give you a little bonus if you remember to put that as ordered pair. Okay. Now let's take a look at 2x. So same place where we put the -1, we're taking out the x, we're replacing it with 2x. So it would be 2x in parentheses squared minus 8 times 2x in parentheses plus 1. Now for those ones, there's not much we can do technically. You know, we really can't do much but make it look prettier and simplify it slightly. To square 2x, 2x times 2x is 4x squared. -8 times 2x is -16x plus 1. And then you can see we got a square, we got an x, we got a 1. There are no like terms, so just leave it. You don't have to go further. Again, feel free to add on the ordered pair, okay, as a way to kind of show that you understand what that means. Now, when we do x plus 8, you definitely want parentheses where the original x is sitting. So where our x is sitting, we definitely need a bigger parenthesis to stick that x plus 8 in. So it's going to be x plus 8 squared minus 8 times x plus 8 plus 1. Now, most people do that portion correct. So I expect that you'll do that piece correct. But the problem is that that's the most common missed piece, this piece right here. So remember, x plus 8 squared means x plus 8 times x plus 8, okay? And if we distribute, we get x squared plus 8x plus 8x plus 64. Or you might recall there is a binomial rule that if you're squaring a binomial, it's the first term squared plus 2 times the product of the two terms plus the last term squared. So if we simplify it up, that's x squared plus 16x plus 64. The first term squared plus 2 times the product plus the last term squared is the rule if you want to do a shortcut. Now let's distribute the -8 to both of those. We get -8x minus 64 plus 1. And then it's just a matter of simplifying as much as you can. Okay, so we can't do anything with the x squared. There's a 16, x minus 8x is positive 8x. And then we have a 64 minus 64 plus 1 is plus 1. So again, you could write that as input x plus 8, get out x squared plus 8x plus 1. Are there any questions about number 10? Is that good? Okay. Now let's do 11. Same idea. Just a slightly different kind of function. So this time our input is a. It is negative 3 times the square root of a squared plus 9. Okay, so if we plug in 4, negative 3 times the square root of 4 squared plus 9. Remember how square roots work. You don't square root the pieces. You get a value, then square root the value. So it's negative 3. 4 squared is 16, 16 plus 9. Make it 25. Then do the square root, because otherwise it'll mess you up. So that's negative 3 times 5, or negative 15. I stick in 4, I get out negative 15. Now the 3a and the a plus 1, you're going to find we can't do a lot. We can do a little bit of simplification, not a lot. So we get negative 3 times the square root of 3a squared, put it in parentheses, plus 9. Again, we cannot do much. It would be negative 3 times the square root of 9a squared plus 9. Now, some of my students, especially at your level and you know the way your brains work, you want to factor a 9 or do something with the 9. At this point, it doesn't help us. There's nothing that requires us to do that. So just leave it. Don't overthink it. And so our input is 3a. Our output is negative 3 square root of 9a squared plus 9. Everybody okay with those first two? Okay. We're going to do the same thing. So it's going to be negative 3 square root of a plus 1 squared plus 9. Now we have to do that trick that a plus 1 squared is a plus 1 times a plus 1. So if it helps you to write 2 of them, feel free to write 2 of them, okay? But when you FOIL that out, you get a squared plus a plus 1 plus 9. Sorry, my 9s and my a's don't look that different. But now, there's not much we can do to this one at all. So it'd be negative 3a squared plus 2a plus 10. Okay? And that's as far as you can go. Your ordered pair would be a plus 1, negative 3 square root of a squared plus 2a plus 10. Again, not much you can do. Okay. Everybody okay with those? Now, if something's written in function notation requires or kind of proves to you it's a function. So, and these would all be functions. Everybody okay with the input into a function? 2 more things that are going to be on the quiz. Domains and piecewise functions are the last 2 things that will be on the quiz. Let's talk about domains. Do you remember the rule that we have to worry about if we're finding the domain of a square root?
No.
The domain of a square root.
Equal to 0, and subtract.
Close. Greater than or equal to 0. Remember, inside. Let's make ourselves a little note. Inside is greater than or equal to 0. It is related to 0, but it's greater than or equal to 0. So you're just going to set negative 3x minus 2 greater than or equal to 0. And then you're going to solve. So we're going to add 2 to both sides. When you divide an inequality by a negative, what do you have to remember to do? When we divide by a negative, what do you got to remember to do? If you divide an inequality by a negative, you have to do what? What did you say? I'm sorry. If you divide by a negative, anybody remember? Circle that symbol, because the rule is you have to switch the symbol now. So if you multiply or divide by a negative, you got to turn the symbol. So we get x is less than or equal to negative 2/3. Now that is the domain. And if you got that far, and let's say the problem was worth 4 points, I'm only going to take off a point if you don't go further. I want it in interval notation. Okay, so just note, I want this answer in interval notation. So, I want the domain to be written. Think about on the number line, this would be at negative 2/3, it would be a closed-in dot. I would shade to the left. So that's going to negative infinity. Boop. And so our interval is from negative infinity to negative 2/3. So I want the interval as an answer. So anytime it's a square root, I want greater than or equal to 0. Now, I want to add like a question 15. Just because it will be a nice little kind of quick little question for you. If you want to find the domain and your function is a polynomial. So like if all the powers are perfect whole numbers, if it's just x squared plus 3x plus 7, 2x plus 8, x to the 5th plus 4x plus 7, so that's a polynomial. If it's a polynomial, the domain is always all real numbers. Or you can say, what I really want, negative infinity to positive infinity. There's no problems. There's nothing I can't stick into that. I can stick in positives, negatives, fractions, square roots. I can stick in whatever I want. That's the beauty of a polynomial, is that I can put into it whatever I want. So there's no problems with the domain. Now if we look at 13, there is a problem with that. Remember, to find the domain of that, the bottom is not allowed to equal 0. So all you're going to do is you're going to take the bottom and you're going to set it equal to 0 and put a slash through it and then solve that. Okay. So how do we solve that? Well, that's factorable. That's t plus 3 and t plus 3. So there's really only one value that's going to mess it up. T plus 3 is not allowed to equal 0. So that's an interesting one, that it just happens to only be one value. Sometimes if it's squared, there might be 2 values. If it's cubed, it might be 3 values, but there's just one value, and the answer would be that we can't be negative 3. So that's your domain. It's t is not allowed to equal negative 3. Again, if you get that far, I want interval notation. So the interval that I want, think about the fact on our number line, the only value we skip is negative 3. So to show that, here's how you show that. I go from negative infinity just to negative 3, and a parenthesis tells me I don't stand there because there's a hole there. I leap across the hole, and then I go from negative 3 to infinity, and I don't have to stop ever again. So look how it follows this perfectly. I'm at negative infinity. I get just to negative 3. I leap across it, and then I keep going. So this has kind of 2 separated pieces, and this has 2 separated pieces. So there are things to remember about domain, 3 things. If it's a good, wonderful polynomial, like a perfect x squared or x cubed or x, it's all real numbers. If it's a square root, the inside has to be greater than or equal to 0. If it's a fraction, just set the bottom equal to 0 and solve it. Everybody good with domain? Okay, the last piece that's going to be on the quiz tomorrow is a piecewise function. I'm going to give you a piecewise function, and it's your job to evaluate a certain value in the correct spot. Okay, so always before you get started, look at the piecewise function and look at where the values lie. So here, negative 2 is our kind of our border, and I can stick anything less than negative 2 here. Anything that's between negative 2 and 11, and I can stick 11 into here. So negative 3 could go in there, negative 1 could go in there, 0, you would use that. And anything bigger than 11, we use this. You get negative 75, which is a good one. Okay. So f of negative 4 goes here. And so that's just 3 times negative 4 squared plus 16. Negative 4 squared is going to be 16. 3 times 16 is 48, plus 16 is 64. So if I plug in negative 4, I have to use this top piece because it's a value less than negative 2. If I plug in 11, I would use this middle piece because 11 is included in that. So that's just the square root of 11 minus 2, or the square root of 9, which is 3. Let's just add a little extra piece in here. Let's say I'm taking f of 20. Since 20 is bigger than 11, the answer, they just kind of did the math for you, is negative 75. Okay? Any questions about what you're going to see on the quiz tomorrow? Any questions about what we're going to see on the quiz tomorrow? It's going to look like this. I will post this video so you have it. I will post that sometime today. So just so you know. Okay? Please make sure at this time you take a picture of this review and put it into Google Classroom. But you may take it home, of course, and study. That's what you want to do. And again, sometime today I will have this in there.
You would like the 15 class.
Yeah.